So, welcome to the Hungarian Natural Language Processing Meetup again. And a big thank goes to Han to accept our invitation, and he will talk about Jina AI on this event. And before Han starts his talk, let me thank the help of Seth Grimes, and let me welcome the members of other NLP meetups from DC, New York, Philadelphia, and the members of the Bay Area Natural Language Processing Meetup. It's very heartwarming to see that the various natural language processing meetups can work together and organize events together. Let's start the last meetup of this summer with Han's talk on Jina AI. Han, the stage is yours.
All right, thanks, Dalton. Can you hear me? Can you all hear me? Yes. Okay. All right. Well, thanks, Dalton, for inviting me, and really honored to be here to share our recent progress on Jina AI. And so before I start, I'd like to just give a short introduction about myself. So I'm the founder and the CEO of Jina AI. So we call ourselves as a neural research company. So I will explain this later. So probably you've never heard about the neural research, right? So neural research is a term that we invented. Right? Well, before that, it's called neural information retrieval. Right? So the idea is really to use deep neural network as the foundation for a search engine. Right? So basically using embedding, let's say word2vec, this kind of embedding, and then use it as the cornerstone, using it as a building block to build large-scale search engine. So this kind of search is called neural search, or neural information retrieval. Right? And before that, so it is Jina AI is a pretty new company. So we just founded in this February, and this year during the pandemic. And before that, I was an engineering lead at Tencent AI Lab. So it's one of the very top research lab in China. And also Tencent is one of the most largest internet company in the world. And I'm also the part of the Tencent open source program office. So I did a lot of open source work. And here, some of you may heard of this fashion and mist, this data set. Right, so I'm the creator of this data set. So this data set is right now really popular. It becomes one of the standard benchmark data set for a lot of machine learning problems. Right, so if you go to TensorFlow website, right, you look at the deep learning tutorial, you will realize that they are using fashion mist. Right, so a lot of tutorials, machine learning 101 course, they are using fashion mist as a starter. The other open source project I previously worked on is BERT as service, right? So BERT, Google BERT, so we are an NLP group, so you must know Google BERT, right? Is a very powerful pre-trained deep learning model that can be used to solve a lot of NLP problems. And BERT as service is Google BERT is released on September 2018, right? And 1 month later, I released BERT as service. So it's basically a network wrapper around the BERT to make BERT more efficient, to make BERT especially more efficient in production. Right? So with BERT as service, you can just use 1 or 2 lines and use BERT in production, and it's really scale. And so this project is really, really popular. And most importantly, it opens a door for many AI engineers, right, to realize that, okay, so now we can really make deep learning, state-of-the-art deep learning model ready in production, right? So this kind of transition. And Yeah, so these are my two open source projects that I did previously. Before that, I was a senior research engineer in Talendo Research, and I did my PhD and master in Germany, in Munich, right? And I'm also part of some like a non-profit organization, including the Linux Foundation, and also the German Chinese Association of AI. So I have a blog. So this is mostly a tech blog. So you can find out more deep dive in terms of the technology, in terms of the let's say Python, deep learning, NLP stuff. And you are also welcome to add my LinkedIn profile. All right. So as I said, so we are a neurosearch company. So our mission is to enable cloud-native neurosearch that is powered by state-of-the-art AI and deep learning. Right? So our mission is really to provide open source solution. Right? We are not a closed source company. Right? We provide open source solution for business and developers. So notice that we are not providing a consumer solution, right? We are not providing a direct solution for consumers. So we are providing a framework, ecosystem for developers and for business, right? And so to allow everyone to search information in all kinds of data with high availability and scalability, right? And yeah, you can imagine we as the next Elastic, right? And yeah. So right now we have two offices. One is in Beijing, one is in Berlin. So we have employees right now. By the end of this month, we will have I think up to 20 employees from maybe 7 countries. So they are very high profile from Microsoft, from Google, Adobe, and so on. Right. And this is our Berlin office. It's located very center in the Alexanderplatz. And this is our Beijing office. All right, so we have some job openings, including AI engineers, front-end, and Python backend, and DevRel specialists. If you are interested in these roles, please send your resume to career@jina.ai. All right, so what do we do as a company, right? So what do we mean? What do I mean by saying we are neurosearch? What problems, what specific problem do we want to solve? Right? To explain that, I want to start with how the traditional search works. Right? So the traditional search is basically a keyword, so a keyword-based search. So you type some keyword in the search bar or search box, and then you found all the documents that somehow hit those keywords. Right? But nowadays, when we look at the search again, right, the input is not necessarily keywords. Right? So they can be long text. They can be long text such as PDF. They can be images. They can be videos, like short videos on TikTok, Instagram, and they could be long video like YouTube. Right? They could be a sound snippet. They could be source code. Right? So let's say you know how to write hello world in Python, right? But you don't know how to write hello world in, let's say, Rust or Java, right? Or Scala, right? So what I want is I want a search engine that somehow I just throw in the Python version of hello world, and it gives me the Java version or whatever other language of hello world, right? And or it could be, the query could be a map, right? And so this is so basically this is if we think about the current nowadays, right? The input is not limited to the keyword, right? So in order to take all this data format into account, right, we need a new search engine, which is not keyword based, which is not token based or symbolic based, right? In order to handle all these, let's say, modalities in a nice way, a nice and coherent way, we need an innovation on the search engine level, right? Not on the, only on the pre-processing or post-processing level, but on the search engine level. Okay, to give you an example, right? Let's start with a demo. And so this demo is pretty abstract, a very common scenario in the e-commerce company, e-commerce company. So the idea is basically called shops look, right? So it's very intuitive. So you basically want to look at the search all the clothes or fashion clothes or dresses that are somehow similar to whatever this model is wearing, right? This is a pretty classic, e-commerce application, right? A lot of e-commerce website is using that, right? But before we start to think about the solution, right, I'll just give you a few minutes to think about how do you want to, so if you have this kind of requirement from your boss, right? So how do you want to implement this shops look, right? How do you want to implement that? So you probably think that, oh yeah, so I'm going to implement this first with TensorFlow, right? Because apparently I cannot use symbolic representation to represent those dress, to represent those flower pattern, right? So I need deep neural network, right? And so I use TensorFlow or PyTorch, whichever is your favorite, right? And apparently I also need Elasticsearch, right? I somehow had to, feed those embeddings into Elastic, but I don't know whether Elastic supports that or not. Probably there are some plugins that I should learn, right? I should read their documentation and then learn how Elastic can store those embeddings, right? And then I have to also learn a little bit about MongoDB, right? Because I need to store all the meta information around, about this fashion clothes, right? Yeah, probably they can also be stored in Elastic, but I don't know because I have no idea. I have no idea about all this technology stack. They are all new to me, including TensorFlow, Elastic, and MongoDB, right? So at the end of the day, you probably spend 1 or 2 months before you get the first prototype, right? A lot of time are wasted on learning different technology stack from all over the place, reading documentation, and also the final results that you get after 1 or 2 months, it's just a prototype. It doesn't scale, right? It's probably you use Python or Java to glue all the technology stack, all the tech stack together, right? You know by heart that this won't scale in production, right? So you build a prototype, you build a toy example, toy system after 1 or 2 months. So this is the current solution. So let's see how Jina solves this problem by presenting. So I'm presenting a Jina hello world. It's not in every language we have this hello world, and let's see how Jina hello worlds look like. So to start with, I'm going to where's my, okay, yeah, because it's full screen, yeah. To start this, I want to, I'm now opening this Jina dashboard. So this is kind of like, the central place where you can manage your search instance, monitor the search instance, and so on, right? And then on the command line, I will just start Jina hello world. Yeah, it's 1 line. And what it does right now is basically it downloads the fashion images data set. So you know this data set, it has 60,000 fashion images, right? So I will use 50,000 of them as index, so as a database. So basically by indexing, I mean, I will store them in some database. Oops, it doesn't work. Okay, so let me check. Let me try this again. So right now it's just downloading. Okay, now it works. So probably there's some port is occupied or something. Okay, as I said, so I will store 50,000 of them into a database, right? And then I will later retrieve them by querying some, by querying some unseen image, completely new images, right? And so this basically simulates the scenario where we have in the shops look. Right? So here we have the indexing, but it's not very intuitive to see from the console, right? So let's look at the dashboard. Here you can basically switch from different microservice, right? So those are all the microservice, and here are the log scrolling. But it's better to see directly from here. Right? So you see, this is the index flow that I was talking about, right? And there is the index flow I was talking about, the neural search. So here after the gateway is just the doorkeeper. It's basically receive all the requests from the outside, right? And it sends the data into encode this part. So this is a microservice. It's an independent process, right? And okay, so the results comes up, but I will visit that later, right? So this is the encoding part. So it will translate the incoming images. It's probably in PNG format, and then translate it into a vector, into one-dimensional vector. Right? So basically, it's embedding. And then the indexer is basically to store those embedding into a quote database, so that we can later more efficient. We can later retrieve them in a very efficient way. Right. So this is basically the flow chart of our indexing procedure, right? So we can also so if you want to tune this thing, right? So you can also say I want to make this encoder more powerful by using some CNN, by using some ResNet. So what you can do is basically just write. Okay, so I'm going to use Google Big Transfer, right? Big Transfer is a model, is a computer vision transfer learning model that Google proposed back in this June, right? And so you can just write something like that, right? And here then it shows a Docker icon here. So it means that you want to run a customized encoding operator here, right? And there are a lot of customization you can do here and here. And there is also a task panel. There is a logs. Oh, okay. Now it's all empty. Yeah, because the task is done. Right. So let's look at the task. Let's look at the result. So this is the result. So the first column basically show you the query images, right? And the remaining part is actually the top K result, like top 50 most visually similar fashion items or images, right? So as you can see here, it's not bad, right? So it's not bad at all. So some like you have all have this kind of styling, but there are some errors, right? Some random errors. For example, this is not very good, right? So this basically, this gives some bags, right? So this is apparently something wrong with the encoding part. But that is also understandable, because if we look at the source code behind Hello World, right? If we look at the source code behind Hello World, you see it is very simple. I mean, Hello World in every language is not trying to prove how powerful this language it is, right? It's trying to show that this language is very easy to pick up. It's very readable. It's very intuitive and straightforward, right? So let's see, how do we build the Hello World? What is going on behind the scene? So this is a Hello World, how we implement Hello World. So we just we first import the flow, right? So we have a flow API in Jina. We first import the flow, and then instantialize a flow, and then we add a encoding part called CNN encoding, right? So this is an operator, or this could be a Docker image, or it could be a Python script. Right? So we just say uses CNN encoding. So in this part, CNN encoding is redefined as as an internal operator, basically using CNN as an encoding, right? And here, and then we basically change this flow by adding another component called simple indexer. Right? So this basically store all the vector and all the meta information in a NumPy array. And then we do index documents. right? The documents basically is a fashion image data set, and that's it. That's it. So you can imagine with Jina, right? You can build shops look in just 5 minutes, right? In comparison that you previously have to spend 1 or 2 months to build such thing. Yeah. Of course, you may argue that, okay, so what is this, right? So this is just a toy example, which doesn't make sense at all, right? So it doesn't, you said that you want to build something for production, right? But this is apparently not for production. Okay, so let's see how do we want to extend based on that, right? So let's say we want to add some parallelization. Right? We want to add, let's say, so we want to have 3 CNNs that do parallel encoding. That we want to have 3 transformers from Hugging Face to do all this parallel encoding for your text, right? No problem. You just add parallel equals 3, right? So this will start with, this will spawn 3 microservices, and it will manage all the routing, load balancing, and so on. Right? So how about storing? How about the storage? So let's say I want to, you know, so some of you may heard of sharding. Sharding is a technology where often people use that in the database system, right? So you want to distribute the data on different machines so that you get better performance and it becomes more reliable, right? Because if one machine died, then no problem. You just start with a replicant or you simply drop this machine, right? Because this only contains part of the data, so no problem. You still have, like, you know, a lot of remaining data that you can use, right? So let's say I want to add sharding into the system, right? So you just write shards equals 3, and that's it. Right? So adding parallelization and sharding is also very, very simple. So also I just mentioned before that you can use dashboard to change the uses, right? To change the Docker image that you want to use, or change the whatever operator Python script you want to use. Or you can even add a host IP address. So what does this do? So this basically spawn another microservice. So in Jina, we call this pod. We call it pod. We start another pod remotely on this machine, right? And so in this case, it's basically not only started pod remotely on this machine, but also this pod is running inside a Docker container, right, with this image encrypted. Right. And you can also do some kind of very fancy things, like for example, let's say one encoding is not enough, right? You want to concat your embedding, right, by using 2 different algorithms, such as you're using word-to-vec and transformers together. Right? So that's no problem. So you just add CNN, ResNet, or in NLP case, it will be transformer, word-to-vec, and then concat them together. Right? So you can see here we use a concat, this kind of operator, and then we write needs EB1. EB1 is basically the embedding one, and the embedding second, the second embedding, right? This concat operator requires this two output, right? And then finally it feeds to the simple indexer, right? And so that's it, right? So it's also very simple. So let's say in the production environment, you don't want to change the code base. So that's no problem. You can also write a YAML file, right? So to define how the flow look like, right? If you don't want to use YAML file, right? So you say, oh, this is just another DSL, right? Another domain specific language. I don't want to learn about that, right? Then you can just use dashboard, right? To drag and drop. To drag and drop new part, to drag and drop to design your flow interactively, right? For example, like this. And then you connect these things together. All right. So far we have seen, we have read about you know, the index flow, but how does query work, right? How does query work? So query is also very simple. So you still have the flow. You still have more or less the same flow, especially in particular with the same CN encoding as a pod, and then use simple indexer as the indexing, right? You still have this kind of structure, but then you add another parameter called port expose, right? So that means it's very straightforward. You expose your port to the outside so that the public can access your flow via this IP address, via this port number, right? And what's different here is that you add another polling strategy to the indexer and add a reducing strategy. So this is also understandable because in the indexing procedure, right? So when we think about you indexing the data, you of course want to distribute the data into different shards, right? But when you try to query the data, you want to query all the shards instead of just one of them, right? So it's basically the matter of one of them or all of them, right? So in the indexing procedure, you want to send the data to one of them. In the query procedure, you want to retrieve the data from all of them, right? So this is difference. And then you just say, okay, so please block it until I exit the program, right? So all in all, as you can see, what Jina can benefit you directly is it saves your time. It saves human time, right? So that's the most important thing, right? So you other people, especially this is super important for startups, for small business. If you want to build some neural search engine, which is, you don't have the manpower to build from scratch, and you don't have time to spend 1 or 2 months to build a neural search engine. Otherwise, you are losing your competitive advantage, right? And then just use Jina, right? So you can do the same task in just 5 minutes. And but beyond, so this is just an example about Hello World, and all the discussion is around Hello World and image search. But apparently, so we can do a lot of things, right, with Jina. So we can do text search, image to image search, video to video search, audio to audio search, or any kinds of document search. So on this URL, right? Oh, sorry. On this URL, not this. So we have a collection of examples which basically show you. Let me see if I have here. Okay, so yeah, we have a collection of examples which basically show you how do you use Jina for image to image search, and here we have video to video search. We also have a QA search, like input a question and found the answer, this kind of thing. But underneath, they are all belong to neural search. Basically, it's the same. The core idea is the same. Right? So you want to use deep neural network as part of the pre-processing, as part of the encoding, as part of the indexing, and as part of the ranking and post-processing. Right? And so for all these applications, for all these search scenarios that requires deep learning to get involved, you can use Jina to build them, right? So if you look at all these features that we have, right, so you can categorize them into two categories, right? So one is multi or cross modality, right? So multi-modality means that you can input a document with images, with text, with video, with sound. This is multi-modality. So this document is a rich document. It's not only text, it has a lot of content, right? Cross-modality means that you want to search from text to image. Right? So you want to input something like a dog running on the country yard, a dog running a fish swim in the whatever swimming pool, and so and then you want to find the image that somehow match the scene that you described. Right? So this is a cross-modality, and another family of features is around cloud native, right? Cloud native means, what is cloud native? Cloud native means microservice. It means containerization. It means CI/CD and DevOps. So these are the features of cloud native applications. And as a summary, right? So if you look at Jina, right? So we actually provide search AI that really aims for production. right? So we are not aiming for a toy example that only running on your laptop, right? We are aiming at something for production, in production, right? And we provide a solution for universal search problem, right? It's not only text, right? Elastic is very good at text. That's we admit, right? So we are not trying to compete Elastic in terms of text search, right? But there are a lot of modalities beyond text, right? So there are images, videos, maps, 3D models, source code. So all these modalities are beyond text, right? And we want to provide a universal framework to solve them, right? And cloud native, as I talked before, and time saver. This is what we observe from the hello world. And finally, plug and play, right? So we also provide a hub, which is basically a marketplace that centralize all the reusable component, right? So that people can share with their colleagues, can share with the community, and you can use that to build your flow, your search applications faster, right? Okay, so the other example is Google's BIT. This is a big transfer, right? So this is something that especially follows the same procedure, right? So you write a flow, but in this case, I don't write a flow in Python API, right? I basically delegate the flow writing to the YAML file, right? I just write the flow in the YAML, right? And the flow is a little bit also complicated than the previous hello world flow, right? It looks like that. And let me see if I can run this. So here I basically wrap everything into a Docker, right? So as you see here, this is called Jina AI Hub app, right? So this is what I mentioned, the plug and play part, right? So you basically can, where is the, okay. So you can wrap each part here, this green thing is a part. Right? You can wrap each part into a container, or you can wrap multiple parts or subflow into a container, right? And you can also wrap end-to-end all from the input to output into one container. And this, in this case, is called app, right? Okay, so let's see if I can start this app. Okay, it seems that it's already started. Let's go to the demo page, Jina box. Okay, so all right. So let's just this is just a front end component which basically try to be a drop-in replacement of the current search box. So basically, the current search box is basically you have to type something, right? And instead of typing, so the new search box, you can drag and drop the images, the audios, and videos into the search box. But in this case, I only index all the Pokemon, right? I only index all the Pokemon. So let's reset this. Oh, it doesn't work. Oh, customer endpoint. Okay, so there is some update on the. Oh, timeout. So usually it's timeout because when I open the Zoom, so the whole computer is kind of slow down. Okay. Anyway, so this is the result. So yeah, it is funny, but it is interesting, but not big surprise, right? So this is just image to image search, right? But as I said, right? So imagine to build a search image to image search in just 5 minutes, right? So this is a benefit that Jina can give you. And this image to image search is not just a toy example. It really can, it can be containerized, can be deployed in production with all this scalability, reusability, and maintenance, right? And I think here you can also use camera. Right? You can also, where is me? Okay, here's me. Okay, so I can also, this is I can also do the live search. So it's basically, yeah. So it captured my black hair. Okay, now it times out. So it's not very stable, but as you can see, it somehow works, right? And all right, so this is the second demo. The demo I want to show it here is that it's not just any image to image search, right? It's based on Google Big Transfer. So it's based on a pre-trained model that is never trained with Pokemon, right? So you can actually get more results. You can actually find more results here in the Pokédex example. Oh, Pokédex. Yeah. No, not this one. In the examples Pokédex. Okay, right here. So you can go to Pokédex and BID. So you see so first of all, you see we have a lot of examples for Jina, right, that you can learn from. And so this is a Google Big Transfer model in the Poké production, right? So this is a result in batch, right? Okay, so that's the second demo, right? And the last demo is actually not about computer vision; it's more about NLP. So I will just play a video here, but it could be very laggy because of when we are streaming on the Zoom. But you can, nevertheless, you can go to our YouTube channel. You can search Jina AI on YouTube, and you can go to our YouTube channel to watch the, the full version. Right. So basically, what does it show here is basically try to query long text, right? Instead of try to query the few keywords. And here you can basically understand Jina is actually segmenting your long text into sentences, but this segmentation is customizable. You can write your own very deep learning based segmentation, right? And it basically try to match based on the chunks that you segmented. And it can also do this kind of live search. Right? And so if you are interested in this example, you can also check out our example repository, which basically show you how to build this from scratch. Okay, so let's make a summary of what Jina is, right? So we have seen many examples and 3 demos about Jina, right? And so the best way to explain what Jina is I will use these 3 analogies. The first is a TensorFlow for search, right? So imagine if we visualize the AI development into an inverse pyramid. Right? So the bottom layer is the computing infrastructure, where we have CPU, GPU, FPGA, and cloud infra, and so on. Right? So on top of that, we have TensorFlow, PyTorch, MXNet, CNTK, MindSpore, this kind of universal deep learning framework. Right? So this universal deep learning framework are very powerful. So you can use it to build, cat dog recognition, but also you can use them to build, play Dota, play StarCraft, try to build an AlphaGo based on TensorFlow or PyTorch. But they are not optimized for search, right? So if you want to use TensorFlow to solve your search problem, right? They are not ready for that, right? Because they are serving for universal purpose, not only for not just for search, right? And on the very top layer, we have the end-to-end applications, or all kinds of AI applications that include machine translation, image recognition, text generation, data compression, this kind of thing. Right? And so how Jina AI, how we as a company position ourselves, is actually 1 layer above the universal deep learning framework. Right? So we try to build an ecosystem, or try to build a layer between the universal deep learning framework and the end-to-end applications. So imagine you are search engineers, right? And you work in the company. And so the next time you want to build a search engine, which is using AI or deep learning, you come to us. You come to use Jina AI, right? You come to use Jina, right? Because we provide the right toolkit, the right framework that you can easily bootstrap with, right? You can easily to get started with. Right? And so this is our position, right? So of course there are some like, you know, for example, Hugging Face. Hugging Face is also providing, you know, a kind of like an NLP framework. But you know, from the NLP side to the end-to-end application, there's still a middle layer, a middle ground in between, right? In order to build something for the consumer, something for solving a domain-specific problem, you still have to rely on some platform, right? And this is actually exactly the gap that we want to fill in. On top of us, we also have some let's say competitors, that including Algolia. Algolia is a search as service company, right? So this is also one way that we can go in the future. And of course, SoundHound is a very end-to-end, right? So it's basically you try to you know, sing a song and then it look for the wave, you know, look for the fingerprint of the what you sing and then look for the similar sounds. So it's very end-to-end application. So the second way to describe what do we do here is we are providing a design pattern, right, for the current, let's say for the current era, right. So remember that when we have this, when we study computer science, right, so we come from different, you know, paradigm. Design paradigm, programming language paradigm. Right? So before, in the very early stage, we have the structured programming. Then we move forward to the object-oriented programming, and right now it's mostly around, you know, asynchronization, this kind of technique. So it's all about concurrency-oriented programming. Right? So when we look at the search system, it basically follows. It has more or less the same pattern. So we move from the catalog, this kind of yellow page search, to the symbolic-based search, and finally to the neural network-based search. Right. So, so basically, you know, so in each era, we have a design pattern which fits to the era best, right? I mean, Elastic and Lucene and Solr, so they come from the text-based search or symbolic-based search. So that fits to that era very nicely, right? But in this era where we have a lot of multimodality data, right, where the search query is not only about text, and so we need a new design pattern in order to build the search system more efficiently. And as I said, this needs a revolution on the engine level, not only on the pre-processing and post-processing level. So of course you can say, yeah, I don't care about concurrency-oriented programming or object-oriented programming. I can feed everything into C, right? You can write everything in C, right? In the structured programming, right? So that's no problem, right? Of course you can feed neural search back into symbolic search and probably back into the catalog search. I believe if you are a hacker or if you are a geek, you can do that. That's no problem. But the most importantly is that is your way of doing that scalable, right? Is your way of doing that really worth the time, right? When other people using a more straightforward design pattern, they can build the same thing more faster than you, right? And more easier than you. And in terms of the maintenance cost, it's also much lower than you. All right, so this is this is another thing. It's a pretty geeky thing. So we call ourselves, we provide first-class support on the AI model, and the first-class citizen is kind of like a concept in the computer science. For example, the integer and the floats, they are basically almost the first-class citizen in nearly all the languages, in nearly all the programming languages. So that means you can use them as a parameter. You can use them as, you know, either put on the left hand or right hand of the equal of the assignment. You can put on both sides, and you can use it in the function parameter. And this is something we call the first class support. Right? And in Jina, we try to build a framework that consider AI model as a first class citizen in our language. Right. Okay, so we already have like a lot of operators, search operators, classic one, deep learning one inside Jina. So you can quickly bootstrap your own search engine using those executors, right? And but intrinsically, right? So internally, Jina has a very lightweight tech stack. Right? It has a very lightweight tech stack. The base dependency is just 5, right? It's just those 5. Protobuf, gRPC, 0MQ, NumPy, and Tornado. That's it. Right? So we really keep ourselves lightweight, and we really keep ourselves lean in terms of when building the framework. But this has a lot of benefits to keep ourselves lean. Is that so we actually can run ourselves on Raspberry Pi, right? So you can even build Jina on Raspberry Pi cluster. Right? So this is very cool. Right? So it supports different architecture, then you can run on different non-standard PC. But like on both ways, we actually have very flexible support. So part of the code is most of our code is written in Python. Part of them are written in Python, and we can also use PyPy and C and Golang to build the low-level things, right? And regarding the high-level support, we support all this kind of deep learning, universal deep learning framework. And in terms of the cloud native features, we support Docker and Kubernetes. We are heavily use Docker and Kubernetes. Okay, so. But regarding I talked a lot about this framework, the TensorFlow for search. But what about the mission for the whole company, for us as a company, right? So our company mission is really to build the ecosystem, not just the one software. Right? So ecosystem looks like that. So we have the core, which is basically the framework that I'm talking about today, right? And then on top of that, we have the hub. Right, so this is model zoo, marketplace, app store, or whatever, right? Whatever you want to call it. But it's not just any app store. You cannot just download games from the hub, right? As I said, the hubs contains 2 types of apps. So one app is basically the end-to-end flow. The other app is basically the building block that is reusable in the flow, right? So these are the 2 types of apps that we have. And then besides that, we have Echoes, which contains a lot of enterprise features such as auditing, logging, persistence, encryption, decryption, security, compliance, this kind of thing, GDPR, right? And finally, on top of that, we have the cloud, which is basically a managed SaaS service, right? And so this is our landscape. Okay, so I think that's pretty much the end. But if you are interested in Jina, you want to learn Jina, right? After hearing my talks, hopefully. So the best way to learn Jina is actually not to have a correct estimation about the Jina, right? About Jina, because unlike my previous project, Jina is a much bigger project, right? It's a framework. So we said that we are TensorFlow for search, right? So you can imagine the complexity behind Jina, and you can imagine there are multiple abstractions in Jina, right? It's not just a one-liner, right? So you cannot expect that you can use Jina as a one-liner, right? There are a lot of abstractions there. There are a lot of APIs with different layers, and so in order to study, so there is a learning curve. So I have to admit that there is a learning curve, but we really try to smooth the learning curve for you, right? So we have Jina 101, which is a very cartoonish book, storybook, tells you the basic idea of Jina, right? So we can also look at that, right? So this is basically the Jina 101. to introduce the idea of what is document chunk in Jina, YAML config, executor, those gear guys, and a piece part, and you know, the family picture, right? And we also have the tutorials, we have the documentation, we also have tech blog, which basically a lot of deep dive, very hacky things, geeky things. Okay, so we have our GitHub issues, very active GitHub issues, and also our community Slack channel, right? Jina-ai.slack.com. So you can join in if you want to keep connection with our core engineering team. And recently we just put our engineering all hands meeting online. So you can go to our YouTube channel to look at what is going on and how do we want to solve some certain issue and what are the questions from our in-house engineers, and we will answer them in the engineering all hands meeting. Okay, as a summary, I think that's pretty much today. Then Jina is a cloud-native neural network, cloud-native neural search framework. It saves your time. It offers first-class AI models, offers support for first-class AI models. Offer first-class support for AI models. Right? So this is the correct way to describe it. And it's a universal search engine search solution, and it is production ready. Right? So we have a lot of features such as scaling, sharding, async IO, REST, and gRPC, this kind of thing. All right. So and that's basically it. And as I said, if you want to keep connection with us, there are some you know, there's links that you can visit, and yeah, so that's basically it. If you are interested in working with us, then please send us your resume to career@jina.ai, and we are happy to have you on board. And thanks everybody for your attention.
Thank you, Han, for your awesome presentation. It was really cool, and yeah, these online meetups like the personal side, but I think you can just email to Han, because the guys at the Jina AI are very open, they are very approachable, and usually they answer to your emails within a reasonable time. So if you want to know more about Jina, just drop them a mail. And let's move to the questions. The first question is about comparing Jina to Elastic. Attendee asked if Jina AI offers any support for GeoSearch.
Okay, so the question is, I know, so Elastic has offered the support either like by native or by plugins. They support GeoSearch, right? So basically like GPS and address, this kind of thing. So basically we are, let's say, we do not want to compete Elastic on something that they already do very well, right? And I don't think there is a competitive advantage over that. And what we are trying to prove is that we can do something Elastic cannot do, especially when it comes to the multimodality and cross-modality, right? And especially when those modality has no real valid representation besides using vector representation, right? Besides using deep neural network to convert them to vector, right? So in those cases, right, we show that we can do something that Elastic cannot, right? And this is actually something that we are focused on.
Okay, great. And let me pick up another question that we talked right before we started the meetup. How do you manage your Okay, let me rephrase it. Okay, how do you manage the community of Jina AI contributors?
This is a very good question. So basically, we are open source companies. That means if you go to opensource.jina.ai, right, you basically see all our progress, day-to-day progress, right? All the commits that we have, all the discussions, internal discussions, and if you join a Slack channel, you can see more about the discussion, the details, right? And I would say, when we do open source, what does open source mean as a company, all right? A lot of companies, they try to they do open source, but they probably don't really aware the spirit behind open source, right? Before this webinar, I just talked to Zoltan, right? I talked to him that open source is not only about publishing the source code to GitHub. It's not about collecting stars. It's not about becoming the trending repository on GitHub, right? It's about open governance. It's about how to maintain, how to sustain your project with the community, right? And this requires a lot of effort, right? And not only technology, not only technical effort, right? But also from other teams, from the DevRel team, from the developer relationship team, from the marketing team, right? It's a joint effort, right? So if you want to keep your software sustainable in the open source community, right? How to engage the community, how to encourage the community to contribute, and how to reward them, and how to balance the in-house development progress with the community request, right? You can of course not ignore the community request, right? But you can also not become a full slave of the community, right? You cannot do nothing but only answer to the community, right? And so how do you balance between these two? Right? So there are a lot of methodology behind those community engagement and community management. If you are interested in this, in this kind of methodology or philosophical things, I strongly recommend you to look at this one. As I said, I previously worked in the Linux Foundation as a board member, right? In the Linux Foundation, there is a to-do group, open source group. This is a kind of like a sub-foundation. Linux Foundation, unlike Apache Foundation is pretty flat and it's project-based. Linux Foundation is actually, they follow an umbrella structure, right? So you have a big foundation, mother foundation, and then you have multiple child foundations. So To-Do is one of the child foundation under the umbrella of Linux Foundation, right? And so the idea of To-Do group is to explain why the company has to do open source and what are the the best practice and when doing open source as a company, right? And so you can imagine this is a To-Do. It's like it provides a guidance. If you as a company, you want to set up your own open source program office in your company, right? And so To-Do basically provides you a guideline and step-by-step workthrough to set up your own open source program office in the company, right? And it has it has a lot of very active member from the from all those very open source related companies like GitHub, Netflix, Twitter, and so on, right? And yeah, as I said, there was also Tencent there, so I was the representative back in the days. Yeah. Yeah. So that's the question to this. That's the answer to this question.
Okay, and the final question is exactly two questions, but I merged them. What is your business model, and do you have any large-scale industrial users?
Yeah, let me first answer the second question. Right? So regarding the large-scale users, we don't have. It's not a shame. It is because right now, in terms of semantic versioning, right? So we are only at 0.4, right? So I would be totally surprised if somebody used this already into, let's say, into day-to-day production, right? I mean, to be honest, it's not ready yet, right? So you can imagine the complexity. So we started from this February. Of course, like beforehand, when I work at Tencent, when I work at Zalando, I used to work in neurosearch. I used to build neurosearch system. So we have a lot of experience in that. But the company officially started from this February, right? So this is only a half year. You can imagine how long time does TensorFlow take from 0.0 to 1.0, right? 1.5 year. They took 1.5 year. And then it took another probably 1 year to upgrade from 1.0 to 2.0, right? So I will give ourselves enough patience and to make a stable and universal foundation for all these kind of search applications, including the large scale. But in terms of the scalability, I'm really not so worried about this, because we actually provide from the day one, we design ourselves as a microservice, very radical microservice strategy. Basically, if you look at our architecture, you realize that nearly all the algorithms are wrapped in its own microservice. It's a very radical strategy. So it means that, and also all the we have the P part, which basically designed in a very decentralized way so that you can scale out without worry about the state, right? Without worry about state. And so based on those reasons, I'm not really so worried about the scalability. But we, of course, like when we talk about scalability, it means scale out and scale up, right? So scale up means that we have to write very nice code to make sure that it's scale up individually to perform individually, right? And so this is something that we are keep improving over time. Right? Okay, so the second question is about a business model, right? So what is a lot of people argue that yeah, so you are doing open source. It's basically let's say a charity, a non-profit organization, right? But we are not. We are actually backed by one of the top investor in the world, right? We are in terms of funding, we have a lot of funding right now. So that's why we are also expanding, and we are aiming to be one of the the role model in the open source community, in the open source software company in this domain, right? And so then eventually, I mean, of course, you cannot rely on VC's money forever, right? After Series A, Series B, Series C, Series D, right? Eventually, you have to survive by make money by yourself, not depending on all this VC's money. Right? And so this comes to the business model, and our business model, just like many other commercial open source software company, we basically follow open core business model, right? Open core, right? So you can look at the open core model. It's basically proposed by GitHub or GitLab, I forgot. But you see a lot of like Kafka, Cassandra, Elastic, MongoDB. They all follow this kind of open core model. So the idea is really to tier the features into different categories, so into different levels, right? And some features are community available, right? That means they are free. And some features are, let's say, for professional, for executive, for directors. And some features are only enterprise only, right? And so we will basically follow the same business model. And this business model can be applied on multiple products, product lines, including the hub, including the cloud, including the echoes. Right? So there are a lot of possibilities here. Yeah. So that's the answer to the question. Yeah.
Thank you very much, Han. And I think if our attendees have any other question, they can approach you via email.
Yeah. Yes. So yes. So if you have any question, feel free to connect me on LinkedIn or by email. So I'm very happy to receive more questions from you. And if you haven't read about Jina, haven't used Jina, then please go to GitHub. It would be good if you give us a star or fork and try to play with the hello world here and try to give it a shot. Yeah.
Thank you very much. And I just have to say sorry to the guys who are affected by the wrong link I sent to some participating meetups, and thanks to the fellow organizers, they finally could join us using the link. It was my fault, sorry guys. And that was August meetup. Next time we meet in September, probably in the beginning of the month, and we will post the program on time. And guys, stay safe, and see you next month. Thanks, Han, again.
Thank you, Zoe. Thank you. Thanks, everybody.
Bye-bye.